Afternoon, everyone. So this is the Recoup residential wastewater heat recovery presentation. So thanks very much for attending today. So a fair amount to get through, so I'll go through, but a general overview on wastewater heat recovery, what it is, how it works, a little bit on product detail, the various product types that Recoup have in the portfolio, what scenarios they're used in, that sort of thing. A look at sort of the regulation for new build Part L, future homes and direction of travel and things. A bit on designing in and a little bit on SAP modelling. I think that we have got a few energy assessors on the list today, so hopefully that will be of interest there. And then just a design walkthrough, case study. I do have some apartments in the background as well, which we can look at if we have some time, and then also just onto a case study. I'll stop at strategic points at the end of each chapter in case there are any questions. My colleague Chris is sat in the background, so if you would prefer to ask questions in the chat, feel free to, and Chris can answer those questions, or if anything is pertinent to the section we've just been talking about, he can relay that to me and we'll go through. So that should be all the housekeeping, I think. So yeah, that's great. Okay, let's go in on it. I'm just noticing that my green screen looks a little bit fuzzy at the back, but that should be okay. So who uses wastewater heat recovery? Well, in the main in the UK, it's used by new build developers, predominantly for standard house types, showers on first floor and above, and it's been used for Part L compliance in the main. So historically with 2013 regs, which we're out of now, it was used fairly ad hoc, would be fair to say, I think, by developers looking maybe to gain sort of the extra 10% or London plan uplift and things like that. So it was used sort of as a measure for over and above standard spec, but certainly for Part L 2021, which we're into now, it's looking like it's much more of a part of standard spec for most volume developers, house builders, either using gas boilers or often with air source heat pumps as well, and we'll come into that as we go. But we have products that are suitable for standard houses with showers on the first floor and above, but also apartments, bungalows, passive house, well, any type of shower realistically. So new build housing is probably about 90% of the market currently for Recoup, but we're seeing a much higher level of interest now, and have done over the last 18 months or so, for things like student accommodation, hotels, areas where obviously Part L for non-residential development is also having an impact as well. And then, as you might expect, anywhere where there's high shower traffic, so sports and leisure facilities, changing rooms, swimming pools, etc. When you've got high shower traffic use, wastewater heat recovery can have a very, very fast ROI, and we can look at some examples of that if we have time towards the end. And then also looking towards the future, and certainly probably the next 12 to 18 months and beyond, we expect housing stock upgrades, domestic retrofit, housing association refurbs, that sort of thing, for EPC upgrades to be a much, much bigger part of the market. So that's sort of coming now. Where we sit right now, we don't quite have the funded drivers for in terms of eco, but that is expected to change in the future. But also we are starting to see larger housing associations and local authorities looking at wastewater heat recovery as part of sort of social housing decarbonisation funds and LAG funding and things. So that's a separate presentation, but we are looking at putting that out in the coming months. So if retrofit is what you're looking at, give us a shout. We can discuss that with you separately. So why use wastewater heat recovery? Well, it's a simple heat exchanger technology, and it can significantly reduce the energy and consequent CO2 required per shower use. So I'll go through how it works in a moment, but essentially it's a heat exchanger that takes the warm heat energy from outgoing shower waste and uses that, recycles that back into the hot water system to be usable energy again. So it really is that no-brainer of money going down the drain. This is preventing your money and your energy going down the drain. Simple, cost-effective Part L compliance is the main reason for use at the moment. Nobody likes to think of their product as a box ticker, but this really does tick the box very, very well for Part L compliance. Very cost effective in terms of installed cost versus the amount of SAP points that can be achieved for both houses and also for apartments as well. So it really is almost a must have at the moment for Part L compliance. And then from the end user side, it can significantly reduce hot water costs per shower. So we'll go into this in a bit of detail at the moment, but a standard wastewater heat recovery pipe installed, for instance, to a master ensuite, we would expect that at standard flow rates to reduce the amount of energy required per shower by about 55 to 58%. So it really is quite an impactful technology. And as you'll see, it's a relatively simple technology to install, especially into new build homes at first fix. And then very importantly, it has no end user interaction requirements. So it's a passive, instantaneous heat exchanger system. It's built into the plumbing infrastructure on the waste and the cold water side. It can't be switched off, it can't be removed, it's got no filters, no consumables, no isolator switches, so it will just simply work every time the shower's switched on. It's just as simple as that. Very easy to design in, and we'll come in, as I said, to some designing case studies as we go through. Essentially, because it has no moving parts, no mechanical, no electrical connections, it is just completely passive, fit and forget. It has a very long working lifespan as well. So again, because it's just a simple heat exchanger in terms of function, there's no moving mechanical parts, nothing really to go wrong there, no bottlenecks or anything within the system. So BEIs have attributed around about a 40 to 60 year working lifespan for vertical wastewater heat recovery systems and a 25-year lifespan for horizontal systems, and we'll look at those as we go through. And then finally, for those of you who might have an eye on embodied carbon and potentially SAP 11 as that's developing, wastewater heat recovery products have a very low embodied carbon. I've got a couple of slides towards the end as well, which we can focus on, but compared to the operational carbon savings per year, the embodied carbon in our products is very, very low. Okay, so as I said, we've got a number of products in the portfolio. The one that we'll focus on mainly is the vertical pipe hex, which is a vertical pipe heat exchanger, and that's going to be the focus of the video here, just to show you how it works. So just as this loads up, sorry, excuse me, that's better. There we go. Okay, so normally when you shower without wastewater heat recovery, showering with a thermostatic mixer valve, your comfortable 40-41 degrees coming out of the shower head will be a mix of around about 70% generated hot water at about 55-60 degrees and about 30% incoming cold water main to temper that hot water from about 10 or 12 degrees normally. So you're getting around about a 70-30 mix. And the thermostatic mixer is designed so that you can get a desired hot water temperature or a mixed temperature at a fixed flow rate. And if there's any changes to the temperature of the hot and cold incoming in the background, the mixer will just simply adjust the ratio to maintain that fixed flow rate and desired temperature. So wastewater heat recovery is required to work with thermostatic mixers for SAP compliance. And essentially, so if you're looking at compliance, it needs to be with a thermostatic mixer. So of that sort of comfortable 40-41 degrees shower, about 85 to 90% of the heat energy would normally go down the drain and be lost out of the building. So it's a big low level sort of energy loss that you've got there. Lots of sort of warm wastewater, about 34-36 degrees, that's normally just going down the drain and leaving the building. So what we do with wastewater heat recovery is quite simply we put a heat exchanger on the outgoing waste. So as you can see here, the warm waste going down the inside of the heat exchanger in this case, and then the waste just goes off to the SVP as normal. So we're not harvesting the grey water, we're not storing the energy or anything, it's instantaneous heat exchange. And at the same time, when you switch the shower on and that warm waste starts going down the drain, cold water will be drawn through the wastewater heat recovery unit to replenish the system. So that cold water coming in at 10 or 12 degrees will be heated to about 25-28 degrees, depending on the shower flow rate and product. So we're getting, immediately you can see we're getting a free energy uplift of around 15 to 18 degrees from the outgoing waste water. And that's the basic premise of wastewater heat recovery. All products work in exactly the same way. Warm waste goes out, cold water main comes in, and it's preheated. But from there are 3 recognised installation methods in SAP, and you've probably heard of, if you've heard of wastewater heat recovery, you'll have heard of System A, System B and System C. So System A is the most efficient method of installation. It's where we send the preheated water that's coming out of the unit to both the cold side of the shower mixer and to the hot water source, whatever that may be. So whether that's a combi, cylinder, air source heat pump, heat interface unit, microwave boiler, it really doesn't matter to us as long as it can accept a preheated cold water feed. And so what happens here is by sending that preheated water to the cold side of the shower mixer, the mixer then adjusts the ratio of hot to cold in favour of more of the free issue cold or the preheated cold side. So from that 70-30 hot that we started with, we now will go to around about a 30-70 mix in favour of free issue cold. So you can see immediately you're using much less hot water per shower just by the thermostatic mixer adjusting the ratio. And that's obviously still maintaining temperature and flow rate. And then also we'll send that preheated water back to the hot water source. So in this case, we're showing a cylinder, and therefore your cylinder now doesn't have to heat up from 10 degrees incoming cold up to 60. It's heating from about 25 to 28 up to 60. So you're using less hot water per shower on one side, and then your hot water that you are producing for the shower is being produced more efficiently on the other side. So that's System A. That's the most efficient method. It's what's called a balanced method, because obviously everything that's coming out of the shower is getting the benefit of preheated, but being preheated on the cold and on the hot side. Conversely, System B is the least efficient by about 20% less efficiency, excuse me, but it's a much simpler method of installation. So all we're doing here is simply we're sending the preheat to the cold side of the mixer. So you can imagine here maybe the cold feed would be teed off from the standard cold feed from above, come down, go through the unit and then back through. So it's completely closed loop from the hot water system. Much simpler method of installation in most cases, and this it still offers significant savings, around about sort of 40% or so in terms of hot water savings per shower. But System B will be used wherever you have secondary wastewater heat recovery units in, for instance, a domestic dwelling. So your primary might be System A or C, and then anything secondary will be System B. And quite simply, that's because if you can imagine, we had 2 wastewater heat recovery pipes and they were both drawing cold through them and feeding back to the cylinder. Whenever the cylinder recharges, it would be pulling through both, and if only one shower's working, then you would be halving your savings or diluting the savings. So SAP will only allow for one wastewater heat recovery unit as System A or C. Everything else has to be System B, and the system mitigates that through the design software. And then just for completeness, System C is where we just feed the preheat to the hot water source only. We don't see this too often in residential scenarios, but where you may see it is if you can imagine you've got a townhouse where maybe a first floor shower and then a second floor shower stacked above that, so stacked bathrooms. To reduce the amount of pipe work without reducing the overall efficiency too much and obviously reduce the cost, you could just have one pipe located on the floor below the first floor shower, and then the waste from both the second floor and the first floor shower could flow into the wastewater heat recovery unit, and then that cold feed will be preheated and just feed the cylinder or boiler, which is probably in a utility room on the ground floor anyway, on that kind of house type. So System C sits in between in terms of efficiency, but it's generally used for scenarios where we might be able to reduce installation costs, and in this case use just one pipe to cover 2 showers. It's worth mentioning that other scenarios will allow us to use multiple showers connected to a single pipe, but this is a good example of that. I'll go through it towards the end. So just to qualify those savings, so System A, the most efficient, as with any heat exchanger, the slower the flow rate across the unit, the higher the efficiency. So this is the tested system efficiency of the wastewater heat exchanger itself. But obviously, as I said, we've only got around, we've got about 85% of the heat energy from the shower head goes down the drain. So the overall energy demand reduction of that heat exchanger is reduced to give a system efficiency of somewhere between about 58 and 55%, depending on shower flow rate. So the old default flow rate in SAP was 11 litres per minute per shower. It can now be specified anywhere between 13.5 down to 5.5 litres per minute. So we seem to be seeing that a lot of SAP assessors are specifying around about sort of 8 and 9 litres per minute now as standard. That means that the efficiency of the wastewater heat recovery system is better and the overall energy reduction is better. So if you are looking at specification, certainly 9 litres per minute seems to be a reasonable balance between efficiency, reduction in obviously water use, and end user comfort. So 8-9 litres per minute is pretty common now that we're seeing. So that's system A efficiency. So as I said, sort of 54 up to 58%. This is slightly higher now actually, because the SAP calcs have been slightly better. And then on system B, we would expect that those flow rates of 11 and 9 to be around about between 40 and 43%. And that purely is a hot water reduction on the system B side. So you're using 40%, for example, less hot water per shower use at 11 litres per minute. Right, I'll just pause there, just see if there's any questions on that part, and then we'll look at the product types in a bit more detail. Anything in the chat, Chris, at all?
No, the only thing we've got is a question about retrofitting, which I think you're going to go into with the easy fit later on.
I'll focus on that a little bit, yeah, as we come through now. So, okay, let's move on a little bit. And so, as I said, the main product, and probably sort of 90% of wastewater heat recovery sales in the UK at the moment, will be vertical pipe products. As I said, because they work so well for standard new build house types, designed they'll generally fit to sort of any shower, first floor and above. And so here we're sort of seeing this would be boxed in next to the SVP on the floor below the shower it connects to. So you can see here in this example, we've actually got the shower tray from above, and then this is also taking on this particular example, taking the shower waste from the bath in the room adjacent on this one. So it's a 2 meter vertical wastewater heat recovery pipe. Recoup products as standard use what we call a turbo rotator. So this is designed, it's essentially a sort of a waste assembly. So where the warm waste comes in yellow here, this is designed to direct the travel of that warm waste. So it begins a cyclonic motion and starts spinning essentially. That then allows it to cling to the inside of the copper heat recovery exchanger. And so we then get what's called thin film heat exchange. So you're maximizing the surface contact of that warm waste water with the inside of the copper heat exchanger. And then that will flow all the way down, as I said, and vent off to the and go off to the SVP as normal. So that's the grey water going off. As you switch on the shower, cold water main comes through, goes around the outside of the exchanger and picks up that heat and then goes off system A, B or C. So in addition to what we supply in the box, so that's the wastewater heat recovery unit and the installation kit, all that's required for most wastewater heat recovery installations is a double check valve on the incoming cold, and then 2 full flow isolation valves on the cold and the preheat, and then just 1/2 inch BSP to whatever pipe size connecting irons. So it really is very, very simple. This would normally be installed at first fix. So you can imagine in terms of an installer at first fix with sort of bare walls and things, it would normally take about 1 to 2 hours of extra plumber's time. So really is very simple at first fix in most cases. Just, you know, part of installing in the plumbing system essentially. The pipe system can be used for, as well as residential. We do see it used, as I said, in hotels, student accommodation, potentially even build to rent apartments where you've got sort of stacked rooms and showers running up along central service risers. So this is just an example of how you might see in maybe a student accommodation build, for example, with back-to-back en suites. You can potentially get two showers running into the same pipe located in the service riser. This would be installed as system B because we're going to have multiple wastewater heat recovery units over the building. Unless of course you've got for instance, a heat interface unit in each room, but generally it's centralized hot water plant. So this type of blueprint can then be replicated all the way up. So if you've got high rise or reasonably low rise apartments or student accommodation builds, this is really a very, very cost effective way of installing wastewater heat recovery. Obviously using 2 showers into 1 pipe, so it makes a lot of sense there. But on a more domestic scenario, we would expect this to box in next to the SVP. So your standard SVP boxing is probably about 220 by 220 mil. With wastewater heat recovery included, you're really only adding about 200 millimeters in one direction. So it really doesn't take up a great deal of footprint, a great deal of real estate, and can be designed into practically anywhere where there's an SVP. It really isn't going to make a lot of difference to your overall design. So it really is good in that respect. Very little sort of aesthetic changes when designing in wastewater heat recovery. So in terms of how the unit works, this is just a cross section straight through the pipe here. So as I said, the warm waste will cling to the inside of the smooth copper heat exchanger. This is a 50 mil internal diameter copper exchanger. And then the cold water comes up between the copper and the PVC here. So this is the exchanger. The eagle-eyed amongst you will see that there are actually striations running through the middle of the exchanger here. So what the construction of the exchanger is a mechanically pulled pipe through another pipe. And so these striations here run the entire length of the heat exchanger and are open at both ends. What this does, it gives us a built-in visible leak detection system. So if ever there was a time when there was a perforation in the exchanger, at first fix, when the product's installed and tested, there would be a visible leak underneath from that cold water going through the exchanger and dropping through. So because we then have a built-in visible leak detection system, what this does, it means that we directly comply to EN 1717, which is to do with potable water mixing with grey water, essentially. And so it means, from a practical point of view, that when you use Recoup products, which are all double-walled exchangers, the shower trap can remain in place under the shower where it belongs, rather than having to be relocated downstream of the wastewater heat recovery unit. So obviously it remains up here where it should be doing the heavy lifting and catching hair and things like that, rather than having to be installed below down here. Obviously, if you do install it below, that then adds potentially things like falling water noise, extra installation height. It means that the trap needs to be accessible, so it can cause other problems. So all of the Recoup products are double-walled exchangers, meaning the trap stays in place, doing what it should be doing under the bath or shower. All of our products as well are stocked and sold by all the national merchants. So certainly from developer supply chain, we can dovetail into existing supply chains really, really well. Certainly in terms of volume developer pricing, we'd probably expect these to be coming through the merchants anywhere between 360 up to sort of 410, 420, I would think about now. But certainly you would expect from a developer point of view, installed sub £500 in most cases. So it really is a very cost-effective option for new build, and can score very highly in terms of SAP points. So that SAP points to installed cost ratio is one of the best that you'll see in terms of SAP listed measures. I've kind of touched on most of this, I think, now, but in terms of installation operation, installation at first fix, 1 to 2 hours of extra plumber's time. Only basic plumbing materials, tools and knowledge are required. So your average jobbing installer will be perfectly happy installing wastewater heat recovery. And certainly we have lots of resource and installation guides that will guide them through that. But there's no specialist training required, no MCS accreditation, nothing like that. It's your qualified installer will be perfectly happy with this. As I said, no planned maintenance, just the same simple routine cleaning that you would do with your shower with wastewater heat recovery is what you would do without wastewater heat recovery. So, if you rod your drains, if you use standard drain cleaners, all of that's perfectly fine with wastewater heat recovery. And very importantly, no behavioural changes. So in most cases, the end user simply won't know that it's there. A slightly wider boxing, maybe in the lounge or something like that, is really the only outward observation that wastewater heat recovery is installed. There really shouldn't be any change to how they shower or the experience of the shower. So that's the vertical pipe hex. Really is the best blend of SAP points, efficiency versus cost. However, because it's gravity fed, it is limited in that it needs to install on the floor below the shower it's connected to. So it works perfectly well for houses where you've got first floor showers and above, or hotel student accommodation, for example. But where you don't, then we have other products in the range, generally termed horizontal products. So the next best mix of cost efficiency is the EasyFit. This is a standalone horizontal wastewater heat recovery system designed primarily to fit directly under a bath, connect to a thermostatic mixer shower over, or it can fit to a suitably sized shower riser tray. So if you've got a riser tray, generally sort of 1400 mil long by about 800, then the EasyFit can be used under that as well. It's not, sorry, I've got missing some bullet points. Not quite as efficient by design as the vertical system, so it's about 2/3 the efficiency. However, because the EasyFit was primarily designed for apartments where shower over bath is normally the primary shower in apartments, the way that SAP calculates SAP scores for apartments versus houses, it actually can score fairly similarly in apartments as the vertical pipe can score on houses. So again, similarly priced, so you can get that a similar blend of cost efficiency or installed cost versus SAP points. Very easy to install, so it works in the same principle. Warm waste goes down one side of the exchanger and vents off to the SVP. Cold water main comes in the opposite side, so we get counterflow heat exchange. In this case, we're using a flat serpentine exchanger that runs through the body of the unit all the way through, and then that comes out preheated. So we've got lots of pipe length, lots of surface area, and the way that this works at sort of standard shower flow rates with the shower water flowing through, it will sort of roll over under, mix around the exchanger. So we're getting lots of mixing and lots of heat exchange, which is why this is still, I think, the sort of best efficiency standalone horizontal system available at the moment. So it really is a good in terms of cost efficiency on this one. It's designed so the exchanger sits about 2 millimeters above the pan, the base of this unit. So at the end of use, when the shower's switched off and the flow is reduced, that grey water will then just trickle through underneath the exchanger, and any debris that might have come through from the bath trap, so maybe hair coming through or whatever, obviously the bath trap does the heavy lifting, but anything that might have got through will just be flushed away. So the unit completely flushes to empty at the end of use. These are designed, obviously, as you can see here, with adjustable legs, so you can just adjust the fall from either end. And the unit is very flexible in that it can be, you can have the waste coming in one end or the other, as long as the cold water main comes in on the opposite end, so we get counterflow heat exchange, and then the legs can lift and be adjusted to fit the scenario. So again, this is sort of showing, this one's showing with the SVP on the opposite side. This is showing how it would be installed if the SPV was on the same side as the bath waste, which is probably a bit more common. You can't quite see here, but there's actually a recess in this unit, so this pipe can sit within almost the much lower than you might expect. Realistically, probably needs somewhere between sort of 95, 105 mil clearance under a bath or shower tray to install the EasyFit in most cases. So it's just some examples showing that. Again, I can link to these, and I'll send you all the presentation afterwards as well if you want to have a look in a bit more detail. So as sort of mentioned, around about sort of similarly priced to the vertical pipe system. So, you know, again, still probably expect installed costs under £500, certainly in most sort of shower over bath scenarios. So again, very good cost efficiency on these. So the EasyFit works very well for showers over baths. It can work well for suitably sized riser trays, but there is a trend, certainly for apartments and DDA bathrooms, for example, for low profile shower trays. Because wastewater heat recovery, whilst it is planned maintenance free, there's no moving of mechanical parts, etc., etc., it does, as a device, it still needs to be reasonably accessible. Now, as a specifier, it would be down to you to decide what's reasonable access, but certainly Recoup we don't term being installed under a shower tray in a floor void, for example, as being reasonably accessible. So we wouldn't suggest that the EasyFit, for instance, would be installed under a low profile riser tray in a floor void, which is why we've then developed the Hex Active. So the Hex Active is essentially a pumped upgrade kit with a proprietary buffer cylinder that is designed to leverage the high efficiency of our current wastewater heat recovery pipe. So it will work with the standard pipe Hex Active or the shorter Hex Active RD. And then all that happens here is that shower waste will flow into a pump. This is actually a Saniflow grey water lift pump. So Saniflow have been in the market, in the grey water lifting market for a long time in the UK. Great products, great pedigree, great warranty. So we've teamed up with Saniflow on this one, and that warm waste will flow into the unit. It has an activation level which will then activate the pump and very rapidly pump up and into the turbo buffer up here. So this is essentially a buffer cylinder with a turbo rotator built within that, and then that will allow that volume of water to fall through the wastewater heat recovery pipe as though it was under gravity. So it's a way of upgrading the existing pipe to be used on the same floor as the shower it connects to. So this then opens up the retrofit market very well for showers, refurbishments of bathrooms, that sort of thing, but also DDA bathrooms and apartment en suites and things like that. Obviously, it's a little more expensive because we've now got a pumped element within this. And also, whilst the wastewater heat recovery unit itself can still be planned maintenance free, so sort of boxed into a service void as we're showing here, the pump unit itself is obviously a mechanical and electrically connected element. So this would need to be accessible. So as we're kind of alluding to here, this could perhaps box in behind a vanity unit or something like that and be accessible there. So it could be considered a compromise to a point because we're introducing the mechanical and pumped component here. But what it does allow specifiers to do is leverage that high efficiency of the vertical pipe system on showers on either ground floor or same floor. So it's again, it's a scenario based solution, this one, but we're certainly seeing a lot of this where we're seeing sort of single living accommodation units that might be sort of low level and maybe 1 or 2 floors using the standard pipe for first and second floor showers running in on service risers, and then the pump system on the ground floor showers. So it really does offer a good solution there to cover all showers on certainly on low rise blocks like that. So I won't dwell on this too much because you might not be able to see too well, but just a schematic on how that works. So we've got need basically 3 degrees fall into the unit. That kind of gives us around about 1 meter or so in most cases to play with. And then the pump itself can be around about 1 meter or so away from the pipe. So there is still a fair amount of flexibility in the design on this one, and certainly for things like podded bathrooms or, as I say, bathrooms with service voids behind showers, this really can be an ideal solution. This is listed on the SAP database as exactly the same SAP efficiency as the standard vertical pipe, as the gravity fed pipe. The reason for this, the way the pump works is it's designed so it works intermittently during showering. So whilst it's a very low nominal wattage pump, in the first place it's a 250 watt pump that we use. It only works for around about 1/3 of the time that the shower's in use. Because we have that buffer cylinder and the pump will pump up at very high velocity, it will activate, it will pump up, the wastewater heat recovery will begin working, and then within that time it will activate again, top up the buffer and continue flowing through. So it works for around about 1/3 of the time that the shower's in use. It's relatively low noise. I can't remember what the decibel levels are off the top of my head, but you know, it's a Saniflow system that's been used in the market for a long time. So there's really no issues with sort of noise and things like that with the unit. But it does give a very low sort of nominal wattage overall for use, something like between about 85 and 95 nominal watts use per shower use on the pump. So it's very low. And then just to complete, we also have a range of wastewater heat recovery integrated wet room drain channels. So don't see these in too many residential scenarios because they are a little bit more expensive than the other products. But where they do really excel is in commercial scenarios. So if you can imagine, you've got shower changing rooms with tiled wet room floors. This is a fantastic product. It just, works in the same way as a standard recessed linear wet room drain channel would do, but in this case, all of the wastewater heat recovery components are within the body of the drain and completely accessible. So what you're seeing here is just a pull away here. So normally what would happen is when you shower, the warm waste is going to flow into the drain unit here, or into the drain void here, onto the percolation plate. Again, the eagle-eyed amongst you will see that there are strategically placed holes in the percolation plate here, which sit directly above the heat exchanger. That then allows for that warm waste to percolate through, drip onto or feed onto the exchanger. So again, we're getting that lots of surface contact, thin film heat exchange. And then that just falls through the drain body, and you can't quite see here, but I think we've got one here, into the trap and then away. So this really is a very neat solution for non-residential showering environments. So changing rooms and swimming pools and things like that. The ROI on that can be really, really fast. We've certainly got gyms and leisure centres where ROI was calculated at sort of sub 1.5 years against gas boilers and things. So really is very good. That's as much as I'll go into on products at the moment. Just to see if there's any questions, Chris.
Only question we had was about electric showers.
Unfortunately, at the moment, wastewater heat recovery doesn't qualify in SAP with electric showers. Technically, it can work. Obviously, you are preheating the cold feed to the shower, but SAP look at that as with a standard electric shower where essentially you have probably one or two heating elements, which essentially are binary other than users turning down dials. What would generally happen is that you would preheat the water going into the shower. The electric shower would just give a much higher flow rate shower and ultimately still be consuming the same amount of electricity to do that. So because there's no way of most standard electric showers maintaining flow but regulating the energy use in the background, they don't work that way. SAP has deemed that most users, if wastewater heat recovery was installed to an electric shower, would simply enjoy a higher flow rate shower and not dial back for the energy savings. So it isn't SAP or EPC compliant currently. That said, we are working on solutions and we're lobbying with BRE and within the SAP groups as well. So we do expect at some point within the near future that there will be options for wastewater heat recovery with electric showers. Probably not your standard off the shelf cheap box shower. It would need to be a thermostatically controlled electric shower, but those are available on the market and they're much more cost effective now as well. So yeah, watch this space. The expectation is that will be coming in at some point in the future. So why is all this important? Well, traditionally, sort of 3-bedroom home 15-20 years ago, around about 1/3 of the energy budget from the home would be used on space heating, excuse me. Normally, reasonably poor fabric, reasonably not so airtight, leaky windows, that sort of thing. So space heating has always been the biggest consumer of energy in the home, with water heating normally being second, somewhere about 18 to 23% is the most quoted numbers. Of that 18 to 23%, or your generated hot water use, about 50%, certainly for houses, and up to maybe 80% in apartments of that generated hot water is normally used for showering, certainly in sort of modern homes, modern living. So showering is a big user of that hot water, and hot water is a relatively big user of energy. And as I said, of that shower water, 85–90% is normally going down the drain, leaving the building. Essentially, it's a big cold bridge, for want of a better word. If it was space heating, it would be seen as a cold bridge. So we're losing a lot of energy that's being generated in the home to the outside environment. So if we look at all those numbers on that kind of average 3-bedroom home, if space heating is around about sort of 60%, 2/3 of the energy use, hot water, generated hot water being about 23%, if half of that is going towards showering and then 85% is going down the drain, that's potentially around about 10% of that home's energy budget that's being lost down the drain. So it really is a big amount of energy that needs to be considered. And when we look at the direction of travel with regulations now, so this is another calculation done on a 3-bedroom home under Part L 2021 regulation, you can see space heating, as you might expect, is coming down, and in fact it's probably a fair amount lower than that on some calculations as well. So space heating is a lesser component by percentage of that home's energy budget, but because there's no reason to think that someone living in a energy efficient 3-bed versus someone that lives next door in a not so efficient 3-bed would shower any differently, the percentage of hot water is relatively higher, even if the absolutes would be the same. And so we've got more energy being, more of that being attributed to showering, and much more potentially relative amount of energy from the home energy budget going down and being lost. So regulation does seem to be considering this now, which is why wastewater heat recovery has been included in the Notional Dwelling for Part L 2021, which is the first time. So it is being considered much more seriously by regulators. And also, if you kind of take this to the more extreme level with passive house, when you've got sort of heating reduced to maybe 10% of the home's energy budget, hot water is a much bigger percentage of that overall generated energy in a home. So it really should be considered going forwards. Whilst it may not have been a priority for older homes where insulation and air tightness was a priority, it is being seen as a priority now where insulation and air tightness is kind of coming up to modern standards. So Part L is Part L 2021 is the current regulation where we are now. Came fully into force, fully transitioned from 15th of June this year. So we are now starting to see that any new build in England, if it's either been passed or if it's been built past, hasn't been in the ground from 15th of June 23, will be built under Part L 2021 regulations. The key changes in Part L, and there's lots of changes, but the bits that kind of headline and relate to wastewater heat recovery. A 31% CO2 reduction for residential and around 27% for non-resi. Notional dwelling has improved fabric. Boiler flow now is mandated at around about 55 degrees, meaning that radiators either need to be bigger or more efficient. And that's really to allow for the heating infrastructure to be upgradable to air source heat pumps in the future. PV is included in the base case, and certainly I don't think I've seen a house type under Part L that's gone through, that's been specified without PV at the moment, but either more or less. But wastewater heat recovery is included in the notional dwelling. So this is where wastewater heat recovery really has been pushed to the forefront for developers and specifies under Part L, and probably why a lot of you are kind of here now. So under Part L 2021, unlike future home standard, where the expectation is that homes will be all electric, as stepping stone regulations, Part L 2021 still allows for gas boilers to be used, and the expectation realistically is probably that 80 to 90% of new builds over the next few years will still be using gas boilers, and that's certainly what we're seeing with the larger developers that we're engaged with, as well as a lot of the regionals as well. Whilst air source absolutely is going to become more dominant at the moment, there certainly seems to be sort of supply chain and more importantly, I think, installer issues with installer knowledge and things for air source to be completely used for all new build. So we're not seeing that at the moment. So developers are erring away from air source heat pump as standard and still sticking with gas boilers in the main, although obviously most are having more future looking sites as well, and pilots and things where they're looking at sort of mixes for net zero and things. So we're working with those as well. But wastewater heat recovery works perfectly well with air source heat pumps. In fact, arguably as part of an air source heat pump solution, it really should be considered. I'll drop into another slide in a moment, but because wastewater heat recovery is reducing the primary hot water demand, and often with air source heat pumps, hot water is one of the trickier parts to produce. Certainly in the winter, when you've got space heating demand and hot water demand, certain air source can struggle. But also with that kind of seasonality, there's throughout the day for usage and things, there's quite a lot of sort of peaks and troughs in terms of air source demand. So with wastewater heat recovery, reducing hot water demand significantly really does complement an air source heat pump solution or ground source, any kind of heat pump solution. So why are developers looking at wastewater heat recovery? Well, it allows for kind of known and existing technologies to be used. The technologies they're still comfortable with: gas, PV, fabric upgrades. Wastewater heat recovery really is looking as a very cost-effective mix for most developers. There's been quite a lot of work done. I don't know if people have seen the Future Homes Hub have done some really good reports on sort of upgrading existing or Part L 2013 spec homes up to sort of Future Home Standard and Part L 2021, and also looking at a number of different scenarios there, both on masonry and timber frame. But essentially they kind of see wastewater heat recovery being used across the board as well, either for the kind of the Part L compliance element with gas boilers, or with that kind of solution-based approach with air source and other hot water sources as well. So it isn't just sort of us saying about this, there's others looking at this as well. It allows for much easier infrastructure transition. So obviously if you've already got existing sites that are probably multi-year sites, gas already piped in and things, obviously to go all electric, that's potentially lots more services that need putting in, lots of transition. So using wastewater heat recovery and gas boilers, or alongside gas boilers, does assist with developments transitioning across. But also wastewater heat recovery is fully scalable as well. So we've certainly been doing a lot of work in the background with Recoup so that we're fully able to supply the lion's share of the new build market going forwards. And we are really sitting about here actually on this kind of hockey stick uplift, which we're expecting to start coming through with first fixed sites in the next few months. So quite an exciting time to be in wastewater heat recovery, but a little bit daunting as well. So the long and short of this really is that wastewater heat recovery is probably going to look like part of the most cost-effective Part L compliance solution for current Part L. Certainly what we're seeing with a number of developers at the moment, where they've been considering a lot of different options and often throwing an awful lot of PV on roofs, is actually that works very well for standard house types in a kind of middle of the roads kind of plot by plot approach. But actually, obviously on development by development, when there might be different demands, different orientation, different shading, PV may not be as impactful. So we're starting to see some developers now come back and relook at introducing wastewater heat recovery more as part of the fabric package. So it's there on the base design. That then allows for a number of PV panels to be reduced, not PV in total, but by reducing maybe from 8 to 5 or 4 panels, it reduced some costs on the standard, but then it gives a bit of headroom on the roof, so that if then more efficiency is needed on a plot by plot or development by development basis, they can simply add in more PV panels, and that's a much more cost effective way to squeeze more out of your Part L spec than it is looking at designing wastewater heat recovery or other measures in after a standard group spec being put in place. So we're certainly starting to see a bit of that coming through now, where things are filtering down from group to regions, that the regions are having to relook at some of the spec from group as well. So certainly worth bearing that in mind, I would say. We're engaged with a number of house builders, but yeah, I mean, across the board, developers are looking at wastewater heat recovery, I think is fair to say. I'll just pause on that before we get into a little bit of designing, just to see if there's anything from there, Chris, to see a few things ping up.
We just had a question about Legionella.
Okay, all products, all installation methods, all Legionella control risk assessed. Sorry, I should have mentioned this at the beginning. We're really not in the Legionella zone, so it's quite a low kind of consideration. The couple of things to bear in mind from a Legionella and designing point of view is where you install the wastewater heat recovery unit, and this really refers to the pipe. It shouldn't be in anywhere where you've got high ambient temperature above 25 degrees, so not in a cylinder cupboard, not in a plant room, not sort of next to any other heat sources. When it's boxed in, it shouldn't be lagged, so you might lag the SVP for acoustic purposes, for example. The wastewater heat recovery unit should be left open so it can cool down as quickly as possible. So don't insulate, no high ambient heat. And then the last thing is the length of pipe work on the system B side. So from the wastewater heat recovery unit to the cold side of the shower mixer needs to be under 4.75 meters in linear length. That's in 15 mil pipe. That's so that then the volume of water in the pipe is, I think it's under about 0.6 liters. So it really is a very low volume of water. We're not really sort of in that high 40s and maintaining any kind of temperature there. We're kind of in the 20s, mid 20s. So we're not high on the Legionella risk profile in that respect. So that's your two caveats. Don't insulate or heat the pipe, and the system B pipe work needs to be under 4.75 meters. I'll touch on that when I go through the design stuff here. So in terms of designing in wastewater heat recovery, probably for sort of 80–90% of new build house types or standard house types, the pipe hex installed as system A to the master ensuite is just going to give you the biggest bang for your buck. In most cases, that will give a big SAP uplift for relatively little cost and nice and easy to design in. Probably the takeaway from this section is anything else, give us a call, we can support you, we can provide documentation and things like that. So, but it is really quite simple to design in. As I said, sort of most apartments, 2–3 bedroom homes would just require one wastewater heat recovery in the main to give a big uplift. Certainly if you can cover all showers with wastewater heat recovery, you're obviously going to get the biggest amount of impact. If you've got larger house types with maybe 2 or 3 bathrooms, potentially you might require multiple wastewater heat recovery units. So in this case, sort of 2 pipes. As I said earlier, the main one is normally going to be system A with anything secondary designed into system B, regardless of the product type. So it's just system A first, system B second. And if you have the opportunity, or if you have showers, sort of en suites and showers over baths next to one another, or you have the opportunity to design them so that are relatively close, we can normally then cover 2 showers using one wastewater heat recovery unit, so a pipe in most cases, and then that obviously increases the cost efficiency. But all of those elements we can advise on, and the guys in the team here, Chris and the other guys, they go through, they churn through house type designs and things for developers and suggest the most cost effective options. In most cases, there's really only one sensible option, but there might be a couple of different options that we can offer you that outside of SAP modeling may be more efficient in terms of installation or utilizing a single wastewater heat recovery unit for multiple showers and things like that. So I'm just going to run through a very simple case study just to try and tie all this in and give some kind of impact, and where we're kind of running relatively close to the 1/2 so I'll zip through this. So what we're looking at here is a fairly standard 3-bedroom home, master ensuite with a thermostatic mixer shower, and then a family bathroom with a standard sort of hand shower. So it doesn't, essentially it's not counted as a showering SAP, so it's just a hand shower on that one. So we've got one shower, and as you would expect, wastewater heat recovery, so that it's pipe hex installed as system A to the master ensuite. That effectively gives 100% coverage of the showers in this scenario. So if you send us floor plans, we can come back to you with a list of options. In this case, there really aren't very many, but we'll always come back with some specification notes, design and installation notes, and also for the SAP assessors, the PCDB number. So you can just pop the number in rather than searching through reams and reams of different wastewater heat recovery products. And so it just simplifies the whole thing for developers and specifiers. In fact, we've just been working on a new system, a new presentation of this, where actually we're marking up drawings with all of this information now. So it's a much more visual thing. So if you send us drawings, we can come back with like that. In terms of SAP modeling, I'll just touch on this, but SAP 10 is much easier to use now. It's an online system, but it does seem to be working fine now, despite a few teething problems. But essentially, if you're modelling wastewater heat recovery in SAP, it's section 28, which is hot water, and you're essentially choose that you're looking at wastewater heat recovery. So it's instantaneous wastewater heat recovery. There aren't any storage systems on the market anymore, although they are listed in SAP. But in our example, you'd be listing wastewater heat recovery 1. So we tick that box. Then you need to choose the product and installation method. So you can either do that from the drop down, or as I've said, if you drop in the PCDB number that we provide you with, that then populates that. You need to then say whether there's any baths or showers on the site. This one actually should be checked for that example that we've shown. And then this is the important part. You need to click the plus button to connect the shower that you've got, that you have with the wastewater heat recovery unit. Sounds really simple, but what we have seen, because this is now an online system, different browsers show this slightly differently, and sometimes this box might be down below here. And we've seen some SAP assessors that have tried to model wastewater heat recovery, not done the connection here, and then it doesn't show any impact. So if you're not seeing any impact from wastewater heat recovery, it's probably because this button hasn't been pressed. That then brings up a dialog box where you can simply connect the shower and choose the hot water source. Excuse me, choose the hot water scenario, and then that will connect through. So that will then obviously output as part of your SAP model. We've done a sort of bit of modelling here. This was done on early SAP actually, but so it's probably increased ever so slightly now. But just to look at that kind of scenario with a 3-bedroom, either a mid-terrace or a detached, system A just to the master ensuite, so exactly the same as what we've had there. Primary energy reduction calculated at around about 10.7, 10.8%. So really big impact in terms of primary energy reduction on that particular house type. And then a calculated CO2 reduction of around about 11%. So you can see it really can be quite impactful. And that's just from a single wastewater heat recovery unit covering the showers on that plot. So yeah, really can be quite impactful, and it'd be interesting if anybody's SAP modelling. I'd be quite happy to have a conversation to see if this aligns with the sort of numbers that you're getting as well. It's always interesting to hear. So that's realistically from a developer and or a developer specification point of view. You don't really need to be looking at too much more than that. Is it getting SAP points, and is it cost effective? Is it cheaper than other options might be to get that Part L compliance? That really is where the ROI is for developers. However, we can produce much more granular calculation sheets if you've got non-resi projects, if you've got housing association projects, that sort of thing, where you need to dip into the ROI in a bit more detail and things. Certainly for sort of SBEM and DSM modelling, this type of thing is really useful. But anyway, I've tied this calculator just to that domestic scenario that we were looking at. So we've got standard SAP defaults for showering throughout. So we're not changing anything here. We're not taking it out of context from SAP modelling. And then using the SAP defaults, which is 2.3 occupants and 0.72 average showers per day. This gives us around about 1.7 kilowatts of energy saving per day, 628 per year, or that translates as, on this example, 58.4% energy reduction per shower use. This is on the PipeHex System A, as we've been discussing. Excuse me. So it really is very impactful. We can then look at that for different fuel types, different fuel costs. This is all based off current energy saving trust data. That will then give sort of ROI, if you're interested in ROI for different fuel types, annual savings, and then we can also look at sort of carbon savings, lifetime carbon savings if you're looking at sort of eco and social housing decarbonisation fund and things like that. What I will suggest is if you can just bear in mind these numbers here. So this is the annual CO2 savings in kilograms against a gas boiler for that 3-bedroom home, and against an air source heat pump. Sorry, that's a heat pump there on that 131 kilograms. I mentioned about embodied carbon. Recoup products are predominantly copper by weight, which is about 70% recycled in terms of source, but also highly recyclable. We use a sort of cradle-to-cradle manufacturing philosophy, and all of the electricity used at the manufacturing site is generated on site. So we have a very, very green manufacturing process. We were lucky enough to work with CIBSE on their embodied carbon standard, TM65. We gave them a lot of manufacturing data and numbers for the pipe hex, and so we got an early look at the carbon saving number on our product. So the embodied carbon used to produce one vertical wastewater heat recovery pipe is 59 kilograms of CO2. So when you compare that to those operational savings that the unit can make in a standard 3-bedroom home, it really is very, very low. I mean, you can imagine, you can't imagine that a sort of an air source heat pump or a boiler or something is ever going to be anywhere near this kind of low number. So yeah, if embodied carbon's on your radar, wastewater heat recovery really does tick the box there as well. I'm going to skip through the apartment one. I mean, needless to say, it just follows the same sort of way really, and just kind of very quickly just go on to a case study. So I mean, Recoup have been involved in the UK market now for sort of coming up for 13 odd years. So, you know, tens of thousands of units installed by new build developers over that time. So I wanted to focus on sort of something looking much more towards the future. We've been lucky enough to be sole supplier to Barratt since 2013. And so we've been working quite closely with Barratt Group Technical. Barratt have their zero carbon roadmap, which they've put together, where they plan to be essentially building net zero homes by 2030. And already they are piloting these net zero homes. So I won't dwell on this too much, but essentially including wastewater heat recovery throughout. So the current 2 pilots that they've got is the Z House, which was completed about 18 months ago. This is a standard Barratt 3-bed house type that's been filled with a number of different sustainable technologies. I'll go into those in a moment. And then also the Energy House 2.0, which is currently being monitored. So that, again, they've built another standard 3-bed home, filled it full of a number of different technologies. Technologies actually are interchangeable, so they can test different configurations. The Energy House is a completely weather generating lab that both a Barratt and a Bellway home, and then there are a couple of others being built in there as well. So it's a big lab that can generate temperatures anywhere from -20 all the way up to +40. So we visited the other week, and they're actually down at 4.5 degrees in, you know, balmy summer weather. So they're simulating all different weather types on houses with different fabric and P&H scenarios in there. So I just want a quick look at the Z House, where wastewater heat recovery has been included. So as I said, this is a standard Barratt house type that's been upgraded to include around about 40 different cutting edge technologies, but all that are on the market at the moment. So everything from biodiversity, sustainability, water saving, and energy efficiency and fabric technologies have been included on this. Wastewater heat recovery included. This was the example that I used earlier. So boxed in the kitchen in this case, and connected to a Kelder air-powered low flow shower on the ensuite. So this runs at about 5.56 litres per minute. And then a shower over bath on the standard bathroom with just a standard flow restricted shower at around about 6 litres per minute on this one. So both are feeding into the wastewater heat recovery. The wastewater heat recovery is installed as expected, you know, behind SVP boxing, and working perfectly well. Interestingly, with this one, it's actually working with air source heat pump and, as I said, low flow showers. So we would be expecting this to be reducing the hot water demand and energy demand for showering by sort of 60% plus in this one. So there should be some data coming out from that shortly. I think they've got occupants in there at the moment, so they're doing lots of different measuring scenarios with that. So I'll stop there just to say thanks everybody for hanging on with us. Sorry it's gone over a little bit. Plenty of resources on the website, on YouTube. We put these videos up as well, so you can always go back over them. I will come back to everybody with links to the recording of the presentation, the slides, and a few other links, but also just to say, as part of our sustainability drive, we're doing a CPD for Trees initiative. Everybody that has attended today, if you fill in the link that we'll send through back to you, we'll donate 25 trees for every attendee. So just part of a way to kind of build sustainability awareness and things. So thanks very much, everyone. I'm available for questions. I can stay on if anybody wants to talk about. I've got other case studies loaded as well. So more than happy to have a chat. But other than that, thanks very much, everybody. Are there any questions, Chris, at all?
No, we're up to date.
Sounds like I've done a good job then. That's great. Right, thanks very much, everybody. I will hold back, but yeah, if you need to contact us, please feel free to. Thank you.